Okay, so let's look at a problem with the discrete Fourier series. Okay, so first one, let's see, given, let's assume that there is a periodic waveform x tilde of n which is looking something like this, where this value 0, it's true, this is n, this is 2, again here 2, 2n minus n, and so on. Okay, so assume that this is a impulse train. I mean, you can see that it's an impulse train, and I can write it mathematically as x tilde of n equal to 2 into summation k equal to minus infinity to infinity delta of n minus k n, right? This is the mathematical expression. I want you guys to find out x tilde of k. Okay, so I can use this is your DFS coefficients for this particular periodic waveform. So I know the formula, that is x tilde of k is equal to summation n equal to 0 to n minus 1. It's over one period, so I can assume any period here. Okay, so here it is n is a it should have n samples. Since n is periodic, I could have till from n equal to 1 till n also. That's not a problem. Okay, so let me have a convenient one, n equal to 0 to n minus 1. Okay, so x tilde of n into e raised to minus j 2 pi k n over n. Okay, so now this guy here goes to, you know that x tilde of n exists only from 0 to n minus 1 in this particular period, from 0 to n minus 1. It exists only at n equal to 0. There is value at only n equal to 0. So if I plug it in here at n equal to 0, if I plug it in, this guy is 0, so I will get a value which is 1. So my x tilde of k is 1 for, and you know that x tilde of k again is periodic, and the period is n, right? So k equal to 0, 1 till n minus 1. You will have x tilde of k as 1. Okay, so now let me see if DFS, the inverse DFS works. So let's assume that x tilde of k, right now this is the answer for you, the DFS coefficient. Okay, so let me just go the reverse way, assuming that x tilde of k is equal to 1. I need to find out x tilde of n. I just want to check verify that this is what you get back. Okay, so here what will happen is, I'll plug it in here again. X tilde of n is equal to 1 upon n summation k equal to 0 to n minus 1 x tilde of k into e raised to j 2 pi k n over n, right? So I know that so this guy turns out to be a 1 upon n summation k equal to 0 to n minus 1 e raised to j 2 pi k n over n, because your x tilde of k is 1. So I can now write 1 by n. I know that this guy here will be turning out to be 1 minus e raised to j 2 pi. Instead of k, I will have a n into n divided by n upon 1 minus e raised to j 2 pi n upon n, right? So now I know from this particular expression, I know that I have already done that only for n equal to 0 or n equal to multiples of n, this value here will be n. For n not equal to multiples of n or n not equal to 0, this value will go to 0, right? This value will go to 0. I know that already. So I can say that this is 1 by n and summation only for the multiples of n, right? So n equal to minus infinity to infinity delta of n minus ln into n. I forgot to add 2 here. Once again, there's a 2 here, there's a 2 here, this will be a 2. Okay, since my amplitude is 2 here in this case, right? This is a 2, so I have to have this value will be 2, this value will be 2. Okay, yeah, here, so this value will be 2 again. Okay, and this value will be 2, so this will be 2 by n, 2 by n. Yeah, so now I know that this is only existing at multiples of ln, so I can write this as n into, so this is actually n equal to minus infinity to infinity delta of n minus ln, right? That's your x tilde of n. For one period this exists only at n equal to 0. For other periods it exists at multiples of ln, where l is an integer. Okay, yeah, so one thing I usually I forgot is the amplitude, to add the amplitude here. So this will be actually 2, this will be 2. Okay, so that's how, yeah. So because I had started off with like the amplitude of this impulse string is 2, so that is what I forgot to add the amplitude. So here, yeah.